All right, so today we're going to look at solving quadratics by completing the square. But before we kind of look at that, I want to give you kind of a concrete example of how completing the square works. So these are algebra tiles. I don't know if you've ever used them before, but basically this is supposed to represent a variable, your x, right? And then if you notice the dimensions of this are the same on both sides for this. So it's an x squared, right? It's an x by x, so x squared. And then these are just little one tiles, right? They're obviously not that well cut out. It's just, kind of to give you an idea of what's going on, okay? So here's what we're going to do is we're going to represent some expressions using these algebra tiles, if you will, and kind of show you how completing the square works. So the first one that we're going to do is we're going to start with x squared plus 6x. Okay, so to represent that using these tiles, I'm going to use obviously an x squared and then 6 of these x tiles. So there's 2, 3, 4, 5, 6. Okay, so here's my expression. So what happens when we talk about completing the square is it's literally about taking these tiles, these shapes, if you will, and trying to make a square out of them. Okay, so I'm going to kind of try to position these in different places to try to end up with a square. And the first thought is oh, well, if I put these like that, that's sort of like a square, but then now it's kind of a rectangle, right? So that doesn't work. But if I kind of rearrange it and maybe put these guys over here, this is a square, right? It's the same in both directions, but I have kind of a hole in it. All right. So what completing the square is it's saying, well, I can take this x squared plus 6x, and in order to complete this square, to make it a full square, I need to add some of these little one tiles. And then how many do I need? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, I know it takes a little bit for me to put them all down. So 9. Okay, so in order to complete the square here, I need to add 9 little one tiles. So to complete the square here, what I would do is I would say, well, I need to add 9, and then that's going to make this a perfect square. Well, what do we mean by it's a perfect square? Well, look at the dimensions of this square, right? This side here, we've got an x, right? So remember this length here is an x. And then each side length is 1, right? See how these are the same side length? So this is an x and then 1, 2, 3 by x, 1, 2, 3. So it's x plus 3 on both sides. And that is what this polynomial factors into. It's x plus 3 times x plus 3, right? 2 factors of 9 that add to 6. Okay, so we've just taken this, and by adding this 9, we caused it to be something factorable. That's a perfect square. It's the same thing on both sides. Okay, all right, so let's take a look at another example. So this time I'm going to do x squared plus 8x. Okay, so what's that going to mean? Well, now instead of just having 6 x's, now I'm going to have 8 of them, right? So kind of going off the same idea, if I want this to be a square, I could add those on there, and then I would just need to fill in these holes, which is a little bit of a nuisance to kind of move all these actual tiles around, which is why we kind of learn it with the tiles, and then after that we start branching out and doing it without the tiles. Right, but if we take a look at this, you could probably figure this out without me actually putting all these out. How many little one tiles do we actually need to fill in this gap? Well, there's 4, 8, 12, 16, right? So to complete the square on this guy, I need to add 16. And then that makes it a complete square, a perfect square, where it's x on this side, and then 1, 2, 3, 4. X, 1, 2, 3, 4. So this is x plus 4 by x plus 4 squared. This is why we call them perfect squares, right? When we talk about square numbers, we call them squares because you make squares out of them. Okay, so this is x plus 4 times x plus 4, and right, 2 factors of 16 that add up to 8, 4 and 4. So it's the same factor on both sides. Okay. All right, well, let's take a look at another one then. So what if we did x squared plus 4x? All right, well, let's try to make some predictions now about what's going to happen without actually using all of these tiles. So x squared plus 4x, right? When I look at this, I'm going to say, okay, well, if I have 4 x's, I'll put 2 on each side so it's nice and even. And then what do I need to fill in this gap? Well, to fill in this gap, I think you can pretty clearly see this is a 2 by 2 gap. So 2 by 2 is 4. So to complete the square on this one, I'm going to need to add 4 tiles, and that makes it an x plus 2 squared. So this is x plus 2 squared. Okay. All right, and then what if I had, as one last example, sorry, I gotta find a color I haven't used yet, it's a challenge, right? If it was just x squared plus 2x, right? Well, x squared plus 2x, I would put half on each side like this, right? And what do I need to fill in the gap? Well, just one tile, right? It's a 1 by 1 section. Okay, so I would add 1 to both sides, and then that makes it an x plus 1 square. Okay, great. So we can kind of see by looking at the tiles, it's pretty easy to figure out what number is going to be added. How can we do that without looking at the actual tiles, though? Well, think about the process that we did for each one of those. When I had the 6x, we took those 6 tiles and we put half on each side, right? Because we wanted them to be the same. So we put half on each side. So half of 6 is 3. And then this is a little 3 by 3 sector. So it was 3 times 3. So we started with this number 6. We had half of them on each side, and that told me that I was going to have a 3 by 3 sector, right? So this number, I took half of it, and then I squared that, and that's where I got the 9. When we did the 8, right, I put half of them on each side, so there's that half again. And then that half number 4, right, this is a 4 by 4 sector. So 4 times 4 is 16, that's where this number came from. So I took half of this number, and then I squared it, and that gave me the 16. Okay, when we did this one, we had 4, so I put half on each side, so it's 2 by 2, right? And then 2 by 2 is 4. So half of how many x's I had, and then squared told me how many 1's go in here. Okay, when it was just the 2 x's, I put half on each side, so there's half as many tiles, and then that number squared, and that's where the 1 came from. Okay, so that's kind of the shortcut for completing the square. You take your x term, your linear term, take half of it, and then square that number. So half of 6 is 3, 3 squared is 9. Half of 8 is 4, 4 squared is 16. Half of 4 is 2, 2 squared is 4. Half of 2 is 1, 1 squared is 1. Okay, so that's the idea of completing the square. So as you can kind of guess from this, completing the square works best when you have an even number here. Okay, if I was going to do an expression like, say, x squared plus 7x, and I wanted to complete the square, well, then things get kind of tricky, right? Because now I'd have to say, okay, well, there's 3 and there's 3, right? But now I've got like 1 left over, and where do I put it? I'd have to put like half on each side or something, right? I'd have to like cut this tile in half the long way and put half here, and then it's going to get kind of messy, right? So as you can sort of imagine, completing the square works best when you have an even number of x's, right? So even number of x's is kind of your best cue for when you're doing completing the square. It also works best when you only have one x squared tile, okay? Because if you have more than one x squared tile, then that's going to kind of screw this up. So if it was like 2x squared, right, instead of just being 1x squared, well, then I've got to incorporate another x squared into my picture, and that complicates things a little bit, okay? So that's where completing the square isn't necessarily as good of a method. All right, but that's your intro to completing the square. We haven't actually looked at how to solve anything with completing the square yet, but this is going to be the step that you will need in the solving process.